So a very warm good afternoon to all the delegates who have logged in from India. A good morning to Europe and US delegates, and an evening to delegates from Asia Pacific. My name is Kailash Shirodkar, and I would like to welcome you all for day 2 at India Water Innovation Week. We had a wonderful day 1 where we had close to 968 delegates, and I'm sure that we will have a wonderful discussion with all the speakers that we have lined up today for you. So to start the session today, I would now like to invite Mr. Bart Jerome, Senior Advisor for International Innovation for Netherlands Enterprise Agency, Netherlands, to do the opening remarks. Bart, over to you.
Okay. Thank you very much, Kailash. Dear participants, speakers, and panelists, welcome to the session for Digital Solutions at the India Water Innovation Week. My name is Bart Bierens, and on behalf of the Netherlands Enterprise Agency, we are proud that the Netherlands is co-host of this event. At our agency, over 4,000 people work on innovation, energy, sustainability, and international affairs. We work closely with our embassy and consulate, but also with Indian organizations like Department for Biotechnology, Department for Science and Technology, TERI, CAI, Ministry of Water Resources, and many others. And we facilitate companies and institutes in their business development with India. And we do this with finance, we establish programs, and by proactive connecting the innovative players with the right business opportunities in India. And I already do this for quite a long time, almost for 10 years, and it still fascinates me to work with India. I worked on several projects and initiatives, and at this moment, I work as interim project manager at a scale-up company called Cool Separations. I work on a project to see if we can bring highly innovative separation technology to the Indian market. And yesterday, our ambassador, Martin van den Berg, spoke of the role of the Netherlands in India in the field of water, and our special international water envoy, Henk Ovink, spoke about designing multi-stakeholder approaches for tackling water issues with Chennai as example. And this initiative is called Water as a Leverage and is now nominated for an International Design Award. And why I'm telling this, that's where I believe where the future is for tackling water-related challenges. It's of course about good governance, it's about multi-stakeholder involvement, but above all, it's also a matter of a design approach. Think as a designer in tackling your challenges and come up with innovative solutions. And it's of course also about innovation. Now this session is on digital solutions, and this has become a major opportunity in a rather conservative water sector. You see, for example, a shift at engineering firms from just consultancy and selling hours. Hold on for a second. From selling hours to a much more integration of innovative solutions. Hold on for a second. Yeah, sorry for the small break. I was talking about the integration of innovative solutions at different firms. And what you see, for example, at the Dutch engineering firm Arcadis, they start a large collaboration project in 2018 with Techstars. Techstars is an international platform for high potential startups and investors. And they were investigating which innovations can be incorporated in their processes. Another example is the use of AquaSuite of Haskoning DHV, also a presenter this afternoon. It's a smart software tool to control water and wastewater processes with predictive analytics. Artificial intelligence combination with meteorological data, satellite, and geographical data opens a whole new horizon with new solutions. And talking about smart solutions in COVID-19 time, KWR, Dutch Knowledge Institute, can track and monitor COVID-19 outbreaks via measuring of sewage water. All these new solutions bring new dynamics in the water sector by collaborating with startups and could possibly lead to disruptive solutions. All these technologies make the water sector smarter, and it will create better solutions and better decisions for industry, but also for policymakers. And as an innovator by heart, I really welcome these new solutions. And to financially support innovative projects, India has launched a Global Stars call for projects with the Netherlands, Austria, Belgium, Finland, France, Sweden, and Switzerland. And with a scope on key enabling technologies for healthcare, agriculture, and water. In the chat function, I will share the website details where you can find more information. And if you have any questions, please contact me after the webinar. I truly believe that if we approach our challenges more as a designer and make better use of the digital solution we have, we can speed up the process in tackling the SDGs. For now, I wish you all a very pleasant and fruitful webinar on digital solutions, and I thank you very much for your attention. Thank you.
Thank you, Bart, for this session. We have for the Digital Day partnered with SWAN, who is a leader association in the space when it comes to digital technologies in the water sector. And I would now like to hand it over to Fred Royan, Global Leader for Sustainability and Circular Economy for Frost, who is going to be the host for the day today. Over to you, Fred.
Hi everyone, thanks Kailash, yeah, thanks for everyone to join us in this session, what we call as the Digital Water Day, as part of the India Innovation Water Week, organized by the Smart Water Waste World, and SWAN is glad to collaborate with Smart Water Waste World for this panel. Just a quick note as well to everyone who's joined in, please place your questions in the Q&A box. I have a few slides about the SWAN Forum and also what we aim to do as part of this event and the focus of accelerating smart water solutions in India. The SWAN Forum established 10 years ago and has close to 200 members now. And the SWAN Forum is pretty much a leading hub when it comes to smart water and wastewater sectors. It's a UK-based non-profit, and it brings together key players in the water sector to accelerate awareness, adoption of data-driven technologies in water and wastewater networks worldwide. The reason I think it's quite exciting is if you look at both the challenge as well as the opportunity in India, there is an increasing demand for water and there's limited supplies. And here is where I see the opportunity for smart water solutions to play a role in a sustainable, circular, and equitable water service for the entire population in India. What the Smart Water Hub or the SWAN Forum is pretty much an agglomeration of various key players. As I mentioned, we have around 200 members, majority of whom are water utilities, but also we do have members who are startup companies, software companies, technology companies, and digital being a collaborative platform where there's a need for collaboration of various players to come together and share their knowledge and expertise to develop innovative solutions. The SWAN Forum is becoming the hub when it comes to the smart water space. And it's really exciting to see the members also participating in this event. We do have water utilities and technology companies who've participated quite excitedly to share their thought leadership and to drive smart water in India. A quick note on the SWAN India Alliance. it's an initiative which we're launching following the success of other regional alliances, because the SWAN Forum has had successful regional alliances which are right now operational in the Americas, in Europe, and the Asia Pacific. The objective is to see how we can drive change in India through the SWAN India Alliance. There's a link here. We put it on the Q&A box or in the chat box for people to have a quick look, but I would encourage all of you to have a look and be part of this agenda for change as we drive the entire smart water revolution in India. Also, a word of thanks for the lead partners, many of whom have who've taken time to participate, to prepare, and to contribute their thought leadership and knowledge for this particular event. And we're really looking forward to the next couple of hours of sharing the knowledge as well as answering some of questions. And I hope everyone attending from this will benefit from this session. What I will do now is introduce our keynote for today, Eva Martinez Diaz, the Smart Services Manager for Aqualia. So Eva is responsible for smart services within the Innovation Department at Aqualia. She takes part in the assessment of state-of-the-art smart technologies, as well as involved in the implementation and evaluating and optimizing them within integral water cycle through international research and development projects. She coordinates several R&D projects from Life Plus, which is an EU initiative, and the Hedge 2020 European programs, leading and conducting businesses with public and private entities in the field of water management, environment, and sustainability. And for me, Aqualia is one of the leading utilities when it comes to the thought leadership on the circular economy. So I will hand it over now to Eva for the keynote. Eva, over to you.
Thank you. Thank you very much, Fred, for the introductions. Thanks also Amir and Swan's friends for inviting me to give the keynote. Good morning, everybody. Suprabhat. My name is Eva Martinez, and I'm head of the Smart Services at the Innovation Department at Aqualia. So Aqualia is a private water management company owned by the Spanish FCC Citizen Services Group and by the Australian IFM Investors Ethical Fund. According to the latest Global Water Intelligence ranking, it is Europe's 4th largest water company in terms of population served and ranks amongst the top 10 worldwide. We are in 70 countries, currently providing services to 25 million users. Almost 70% of the turnover corresponds to the domestic market in Spain, and the rest is international market, mainly in Czech Republic, Egypt, Italy, Colombia, and Algeria, to name a few. Our three main business models are the municipal concession for the management of the end-to-end water cycle, and public services such as collection, treatment, purification, distribution, and sanitation, as well as the analysis of the water quality, infrastructure concessions in BOT contracts, and operational maintenance services and EPC models. It is an honor for me to be here and start this day full of experts and impressive speakers. We all need this expertise as we are facing some pressing, unavoidable, and in need of response challenges. From a global context, the water service providers are facing similar challenges. You all already know that 60% of the world population is projected to live in urban areas by 2050, as it says United Nations, and that according to UNESCO, 47% of the world's population will live in water-stressed areas by 2030. But there is no need to talk about future issues, as already now in India, the water supply demand is unbalanced. India's population is around 16% of the world, with only a 4% of available fresh water. Additionally, only 27% of wastewater gets treatment. So as in the rest of the world, climate change is also affecting the scarcity of water resources. Drinking water is becoming less available as a result of natural disasters and flooding, leading to an overexploitation of aquifers and an increasing volume of polluted water. That is, there is an urgent need to ensure greater water security in the medium and long term in terms of quantity and quality. So I wanted to start with some good news, and probably I haven't done it very well so far. But all these challenges also means great opportunities to be able to improve and find creative solutions for the use, allocation, and distribution of water, while balancing competition between sectors. So in this context of opportunities, I wanted to share with you the journey of Aqualia towards serving sustainable services, using digital solutions, and our dream of a smart water system. I would say that the water sector in Spain has improved significantly in the past decades due to a number of efforts, different stakeholders, and use of advanced technology. The non-revenue water has decreased by 30% in the past 25 years. Household consumption has also decreased by 20% in 10 years, down to an average of 132 liters per person per day in 2016. There is a total access to water services. If ever, COVID-19 has made us more aware of the importance of achieving continuity in the supply services and maintaining the water quality. So the water service of the future that I wanted to share with you is the one of a smart water service ecosystem. So now you can press now the following slide. The smart water service ecosystem, where the relationships and connections between the different elements in the system become as important as the independent elements in the water cycle. So the idea shown here is to have decentralized water services and decision-making, an intelligent digital framework, carbon-free, involving all relevant stakeholders to make society embrace the true value of the water and in line with the concept of a resilient circular economy. Alternative water sources will result from customized data-driven infrastructures that enable 100% of reuse of water, desalination, and the optimization of resources, becoming a more resilient water service. So for that, we need digital tools. But how do you make your organization smart? Let me show you briefly Aqualia's journey from the perspective of the innovation department. Because, yeah, we talk about new and state-of-the-art technologies, but then the most important matter is the reliable water service 24/7. So how does that match? No, it's not easy, as you might know. So if you press the following slide, we started with a number of pilots spread at different locations where Aqualia operates in Spain, adopting and adapting technologies to the different circumstances in order to prove business case, return of investment for those skeptical about digitalization. So some of our pilots included, for example, to name a few, about water quality. We used in SmartIC, we used a multi-parametric sensor to measure the water quality at the reservoir and study its profile along the seasons. So we created an algorithm establishing the quality of the water, good, fair, low, and using it to adjust the chemical dosage at the water treatment linking plant. We also did a few pilots addressing leakages. The focus was always to use numerical optimization techniques to get the most of the leakage detection and localization. So we've been using different softwares with advanced analytics, able to find non-revenue water and establishing consumption patterns. Different strategies have been used depending on the network. We've been working using an advanced system support system to define automatically the optimal permanent DMA, the district meter areas, using different clustering and divided algorithms based on energy and topological metrics. Other softwares we have used with big DMAs to reduce the leak positioning and sizing while optimizing the meter replacement policy. Also, another example, we've used cognitive analytics developed in collaboration with IBM for the operation of a wastewater treatment plant, allowing a reduction of energy consumption in more than 10%. And so with all these pilots, the following step was to implement a fresh thinking approach. We wanted to become a more technological utility and to think of the water service from a holistic perspective, including data, processes, and people. So traditionally, business knowledge originates in independent information silos. We have CRMs, SCADAs. With the new technologies, we can move from individual entities working isolated to globally connected systems to achieve a better global understanding and thus more efficient management. So the following step was clear. Aqualia started developing the water analytics platform to capture the information from all different sources, using multiple communication technologies and multiple technological field solutions. This way, we have a greater capacity to adapt and flexibility to prescribe IoT solutions based on the specific needs at each site. We are now in the process of developing and implementing mathematical algorithms, enabling the identification of anomalous behaviors, improving the network's hydraulic performance, and so on, obtaining a global perspective of the integrated water cycle with implications for overall efficiency. Also, an important driver here is to maintain the knowledge within the organization, as it might happen that the knowledge sometimes is in the people, but sometimes not shared by the whole organization. So the deployment of this platform was done first in Denia service, and later is being extended to the rest of the municipalities with remote reading systems and with intelligent network management projects. Along with the development of the platform last year, the implementation of the business intelligence models, the BIM methodology, was completed. If you press the next slide. During this time, Aqualia has been working to address projects that require the preparation of or maintenance of a BIM model for the project. The Aqualia BIM models will be also used in the operation and maintenance phase for the installation, as it is possible to fit our asset and maintenance management tools. And so I would like also to go further from operation and show you another example of digitalization that is not only improving efficiency, but also allowing new business and circular models. This is about the project Run for Life, a new business model towards a real water smart society. So the idea here is to apply nutrient recovery at the source, increasing recuperation rates by treating concentrated streams. The nutrients produced, fertilizers, and reclaimed water are analyzed for being reused in agriculture, industry, and toilets. This scope allows decentralization using different reactors or technologies implemented at neighborhoods or communities, increasing resilience. With this approach, we get rid of conventional, centralized, and linear approach that only recovers a small fraction of diluted nutrients. Highly diluted municipal water does not have to be pumped miles away to the treatment plants. Nowadays, we know that municipal wastewater treatment plants remove from 80 to 90% of the phosphorus and more than 70% of the nitrogen to fulfill the discharge limits at a considerable expense. This model is an attractive alternative where centralized systems do not exist, the existing sewerage is old or leaky, or existing wastewater treatment plants are overloaded. These new models need digital tools, not only to monitor and to simulate the process and control a large number of plants spread, but also to increase stakeholder engagement through different channels, apps, webs, to increase their knowledge on the process and to make them also feel that they are responsible for becoming part of the solution, supporting the participation of local communities in improving the water and sanitation management. So then, following with people and communities, I would tackle the smart cities, where the ultimate objective is to improve the citizens' quality of life. The best example, or the one I like the best, is Santander, that has been working towards the concept of a smart city for many years already, and where the city is equipped with more than 20,000 sensors. These are distributed throughout the city to measure environment, parking, lighting, and so on. Regarding the water, the Smart Water project started more than 2 years ago with the partitioning of the water network, modeling, use of flow sensors and pressure valves, adjusting the pressure of the network to real water consumption, monitoring of water quality, and decreasing leakage rate, leading to savings of water and energy. We've saved around 30% in energy and 23% water losses compared to previous years. Additionally, I would like to remark the efforts to communication with the customers using different channels. Aqualia's app for citizens is giving graphically the consumption with time range, possibility of comparison with yourself or with on different dates or with others of the same category, and report incidences. There are also panels giving information about the flow and quality of the water, increasing visibility of the water. The evolution of communication technologies means that management can be closer to the citizen, companies can offer new and enhanced services to citizens, such as communications, warnings about municipal consumption, and recommendations for responsible consumption. I would like to mention another example in the island of Ibiza, that through awareness raising activities on the good use of water using different channels, achievements have been made in reducing water consumption, consuming in 2019 92 million liters of water, less than in 2017. And this in turn avoids the extraction of millions of liters of underground catchment, enabling the recovery of the aquifers in the island. And so together with the idea of the smart cities and coming back to our initial stage of showing business case and return of investment, another key aspect is the need for collaboration with governments and municipalities to implement effective models for water management, developing smart cities, converting cities into centers with interconnected structures for a more efficient management of services. This could be possible through the public-private collaboration mechanisms to find long-term solutions to have efficient but also resilient infrastructures. And so to finish, just a few trends for the future of smart, inclusive, and resilient water services. Bearing in mind that the main objective is to keep moving towards value creation. So we talk about trends, technologically speaking, we can mention big data and cloud services, and integration of data from various sources, keep working on better models, digital twins, a bigger role for artificial intelligence, more informed decision-making, more resilient cyber-physical system and services, more secure remote operations. But most importantly, I wanted to mention trends that mean the shift in minds. We have to talk about performance, not only in terms of efficiency, but also in terms of sustainability. Also bear in mind that digital transformation is made by and also for the people. And also we have to take into account that digital solutions have the potential to address equity in water. How? Through transparency in resource allocation, increasing quality and water services for all, through public involvement and access to information, and through monitoring water resources to help identify inefficiencies and inequalities. And also, why not promoting water financing and tariffs supporting access to water for all? So we know that there is an interdependence between environmental balance and social well-being. If we are able to put our capacity for innovation and transformation, including technology, into raising our environmental ambitions and making a holistic water management, we believe that these efforts will have an impact on the environment, people and society's well-being, creating a real water-smart economy and society. And so for the final slide, I just wanted to finish with a picture of our innovation team at Aqualia. They are all smart and resilient people, and they are the ones that are making the future a present reality. Thanks to them, and thanks to you for your attention.
Thanks so much. Thanks so much, Eva. Quite an exciting keynote, and you highlighted on some key points, the challenges in terms of supply demand that India faces, the climate change, but also the ultimate focus on value creation and where digital can play a role, not just in sustainable and circular, but also more importantly on value creation. There are quite a lot of questions, Eva, but just in the context of time, I just need to move on to the next panel.
Sure.
Pass on the questions onto your chat box, and that would be great if you can answer them on that. But thanks again for your keynote, and thanks for joining us today.
Thank you.
Yeah. Great. Moving on. So panel one, we have 3 panels today, and leading panel one, the topic being on digital transformation in the new normal. We have Jennifer Ribeiro, who's the Chief Information Officer at City Wastewater. Over the last 20 years, she has managed a number of operations and projects ranging across a wide set of industries, from banking and finance, transport, manufacturing, property services, telecommunications, and government. Jennifer's core strengths are her people focus, business mindset, and having the courage to bring bold ideas to life through determination, influence, cross-organizational collaboration, and hard work. Pretty much the essence of digital there. And Jennifer has an MBA and a Bachelor's of Business, is a graduate member of the Australian Institute of Company Directors, and is currently a member of the IWN Executive. Jennifer, over to you.
Thank you, Fred, and namaste, and thank you for having me today at India Water Innovation Week and the Swan Digital Water Session. As Fred mentioned, I'm the Chief Information Officer for City Wastewater, and City Wastewater is one of the 3 metropolitan Melbourne water retailers. We have a large number of customers, over 1 million, and to some of you, we have some very key landmarks in our space, the MCG and the Melbourne Tennis Centre, to name a couple. I'm also a member of the Swan Council. Today, I'm very honoured to moderate the first panel of distinguished speakers to discuss digital transformation in the new normal. As Fred mentioned, we have 4 speakers today. Our first speaker will be Rebecca Harrison, Becky, who is the Optimisation Strategy Manager at Anglian Water, Pierre Vittorio Reba, who is the Head of Technology at ABB Power and Water, Morton Rees, the Group Director at Water Utility Grundfos, and Ken Thompson, the Global Technology Lead for IoT and Smart Sensors at Jacobs, and is also the Swan Chairman. So just a quick reminder again to put your questions in the Q&A box throughout the presentations, and during question time we will answer them. So firstly to Becky. Becky is the Optimisation Strategy Manager in Anglian Water. She's responsible for a team of engineers, analysts and process managers who develop and deliver innovation into water recycling. A key part of her role is to distill business plans into digital strategies and ensure the right digital capability is delivered to meet business goals. Other bits that you might want to have Becky be interested in is her 13 years experience in the water industry and her various different roles in water recycling and her Bachelor of Science and Environmental and her Masters in Business Strategy. Over to you, Becky.
Thank you very much, Jen. So I was asked to speak today about digital in the new world, and I had a thought about which case study I might want to run through, and I chose the Rising Main Performance Monitoring because, well, for 2 reasons really. It's kind of key, well, it's at my heart at the moment for 2 main reasons. One would be green recovery, so looking at an environmental economic recovery, and rising mains are one of our biggest contributors towards pollutions in Anglian Water. So making sure that we understand how to better manage their performance is crucial for us at this time. But also, when we look at this new world, obviously we could look towards the digital enablement to allow thousands of people to move from working in offices to working at home, which has been extraordinary across lots of industries. Working in an operational environment, we also had to look at how we can harness digital capabilities to help optimize the utilization of our workforce, with the knowledge that we're likely to start to see a reduction in availability, whether it's to do with shielding, isolation, whether it's to do with illness or bereavement. So we had to recognize that we needed to operate slightly differently in this new world, both from the sort of working at home strategies, but also from the operational strategies. So I chose this one because it's quite neat, but it also speaks to some key areas around the current crises on this, so I'll move on. So when we start looking at digital enablement within water recycling, so we are quite new to it, quite honestly, so it's not quite as mature or advanced as our water partners, but we have over the last 5 years been entering into it to get as much benefit as possible. So what we tend to do, because we have quite a legacy stock, so for Anglian Water we have over 1,200 sewage treatment works, over 75,000 kilometres of wastewater network and over 4,500 kilometres of rising main. So we've got quite a significant legacy stock. So what we tend to do is start looking at a strategy for the type of asset or process that we're looking to apply digital capability to, because we're not likely to ever try and enable all of our assets to be digital or smart. We will focus it as best as possible. So in this case, we look at categorization based on static risk factors. So if we were to fail, which ones are going to be most impactful to the environment, to our customers and financially? And then we start to overlay performance with that to give us that more likelihood factor. which gives us this sort of criticality matrix, and as you would expect, fewer at the top and more at the bottom, which allows us to really focus our attentions. And then we can start applying more sophisticated operating and maintenance strategies. So on to the next slide. So and I'm going to say it's about 2,000 kilometres of our rising main, we started to look at generating condition-based maintenance strategies, and then an evolution towards more modelling capabilities, so prescriptive modelling, and then through to the automation, so fully optimised. And we go through this timeline, and you'll see it's quite long, and over this current time of the pandemic, we have started to reduce that timeline quite significantly. So a lot of our learning has enabled quite a lot of acceleration in this part. Specifically around the automation, we didn't plan for that for another year, and we have started to deliver out. So on this timeline, you can see we tend to do the normal. We do some trialing of technologies, really understand the results and work out which is the best for us. And then we scale sort of a small scale delivery to really get the training data to allow for insight and understand exactly what we're able to get. So in this case, it was pressure monitoring on rising mains, and it was high resolution. So I'm going to say roughly about 100 points per second, so that we could start to really understand exactly what the performance of that asset was. We were then able to create burst alerts, which was really great for us, because one of the big problems that we've had with the legacy stock is that we were quite blind on the majority of our network, rising mains and gravity sewers. So this allowed us to give ourselves a warning to let us know that we had a burst and that we would get there before we had such a significant impact. And that was very successful. It put us ahead of the game slightly. We then scaled up that deployment. So we've got about 200 sites now with that capability on. So following that, we started to look at more intelligence. So we moved into this sort of modelling world, so data modelling, data visualization, where we started to use a tool called Wanda for surge modelling. And what that allowed us to do was have a sort of forecast view of what the likely running performance was going to be on the asset. So if we continue to run as we were, how frequently would it likely burst, and what alternate investment strategies were available to us, recognising that we're not able to repair or replace every single length of rising main that may become problematic or maybe underperforming. And that led to a number of different strategies for investment, which have all been quite effective. And it's also allowed us to put in some operating changes and some sort of educational tools for our operators. And then we moved into the final element, which was about that reaction time, or the time to respond, which is one of our biggest risks, particularly in the pandemic. We know we've got less staff, so what we don't want to have is these incidents that demand our time and demand we attend relatively quickly. So we wanted to look at utilising storage capacity, so turning off our pump stations remotely to give us a minimum of 4, but up to 12, maybe even 20 hours storage capacity for time to respond. What that also meant was that we had a broader pool of people to pull on. So the immediacy of an incident would require one of our technicians to go out. Whereas if we turn off the pump station and don't have the incident and the impact, we can pull on a resource of tankers and jetters to manage and mitigate the impact before we have an incident, and allow us, again, a lot more time to sort of plan on more valued resources. So I'm going to talk through this into a little bit more detail if we go to the next slide. So what does it actually look like? So this is one of the extracts from the system that we use, which just shows the type of data that we're getting through. So you can see on this instance, we have 2 pumps performing fairly well, and then one's performance reduces, and then both start to underperform, and the static head goes completely. Not all bursts look the same, so different material types and the different profiles of rising mains will have different pressures overall, but we were able to start identifying what the standard shape of a burst looks like, to the point that we have about an 80% confidence now that when the system identifies a burst, we are confident that we should go out and attend, and that we are in the burst state, which is really fantastic news. The system also allows our analysts to interact with it and manage those set points, so that when we do get some erroneous results, we can start to really break down that and start to put in some manual or human learning to improve the modelling overall. If we go on to the next slide. What it's also allowed for is for taking out additional data sets. So where this was initially intended to help us identify failure, we were also able to start picking out some of those performance parameters, which are especially good when we start looking at the efficiency of assets. So our pump stations, we have, as I say, over 6,000 pump stations with much more than 15,000 pumps. So their performance is important because they are big energy consumers. So we can start to look at matching the pumps and starting to realise when they're underperforming and actually start doing some diagnostics. So with this particular report, we can start to see when we've either got the hydraulics are failing or when we've got non-return valves that are ineffective. And it means that we can distribute work, we can understand what the payback period is, we can understand when we should attend, and it allows us to better manage that asset group. If we move on to the next one. So the condition and performance monitoring bit we've got quite nicely. We've had it for 2-3 years now and have really started to mature. We then moved into this modelling world. So we started to use surge modelling to really understand what the pressure profile was actually doing to the condition of the rising main itself. And using that tool, we were able to start putting in interventions in the sort of virtual world to understand how to best intervene in the real world. So we were able to look at things like air valves. And air valves, notoriously, there are many, they get hit, they have problems, and you can't always distinguish the value of repairing, maintaining, or replacing. And this gave us a really great tool to start to develop our air valve replacement strategy, which has been really effective. So we were able to look at exactly the value, not only to the condition of the asset and its life, but also to the operating efficiency. So off the back of that, we developed and have started to deploy a new air valve strategy. It also allowed us to look at things like VSDs and the use of those to reduce wear on the asset, but again, also to generate a degree of energy efficiency. So as a result of that, a number of the rising mains that we would have initially planned to refurbish or repair, instead we've able to put in either different pump types or better air valves, which has not only reduced the operating cost of the asset, but has actually prolonged the life. And we started doing this about 2 years ago, and one particular asset that we have in mind would burst between 6 and 8 times per year. Since having put that in, it hasn't burst at all. And that was a 3-yearly profile. So nothing other than those interventions have been put in place, which speaks to the benefit of understanding exactly the operating parameters of the asset and how you can start to approach them slightly differently. If we go on to the next slide. So here's an example of the changes. So using sort of the standard stop starts, we were having 11.6 bars during the shutdown of the pump, and the pressure oscillating to settle at 5.6. When we put in the VSDs, we were seeing significantly lower pressure at the shutdown, so 10.5 bars with a 4.6 pressure spike, which allowed us, it has shown, and this is the site that has had no burst since input, has shown that it had a genuine effect on the asset and the life of the rising main itself. If we go on to the next slide. And then the final element, the bit that we hadn't planned to do for at least another year, until we've done some more learning, but that the current pandemic necessitated, was the automation of assets. And as I say, this is to do with, if we have a burst, we know that our pumps will continue to pump and then pump into the environment. And what this has allowed us to do is see the burst state and stop our pumps pumping, therefore containing any impact within the wet valve, allowing us to get out to site with tankers or other mitigation to prevent any environmental consequence, which is really fantastic. And if we go on to the next slide, it just goes to show some of the architecture was able to deliver quite quickly. So this particular solution, it goes to a third-party platform and then comes into what is our OT platform, which is an Azure type platform that interfaces with our existing telemetry system, which is IRIS. So that allows us to take really high resolution, high frequency data, put it into a more effective data storage world, and then push out responses into our IRIS, which is our eyes and ears. It's what we respond to, it's what generates our alerts for operational technicians. And then what we've been able to do subsequently is open IRIS up to speak directly down to the site. So IRIS can now drive commands down as a result of the data found elsewhere. So this is a capability we've not had previously, but which opens up a lot of opportunity for us, not only from resets and other things, but weather-related control, all those sorts of factors that we haven't had previously. So it's a really good opportunity for us to start doing some much more intelligent remote management to, again, effectively utilise the resources we have on the ground. Thank you very much for your time.
Thanks very much, Becky. And we'll move now on to Pierre Vittorio Reba. Pierre of ABB has 15 years of international managerial experience in different industries, ICT, automotive, and oil and gas, developing products and strategies, coordinating business areas and global programs, working both on the business and then from a consultancy perspective. Over to you, Pierre.
Hi. So nice to be here with all of you. Thank you. And it's a pleasure, of course, to have this chance to be in this exciting world of water that I believe everybody knows is the new oil. And so it's probably one of the most important, if not the most important things that we have today and in our future. So, well, as ABB, we are playing since probably since ever in the automation field, as probably everybody knows, in different industries, and water is one of these industry. And today, what we're doing is not only to continue playing in the automation sector, but transforming this automation in digital automation. That means optimizing process and energy around the water asset and the water networks, together with advanced and optimized automation. So this is what we are doing. We also provide new interesting sensors for water. So these are probably the most important areas. Now, we cover probably different areas in the water sector, in the water project. So we have solutions for water distribution, for water transmission, and therefore we have projects, active projects, as well as already done projects in this area. But also in wastewater, in water desalination and water irrigation. So these are the most important areas where we have active projects. Now we select here, well, just a couple of projects, and that we will see in a while now. So first one is, well, I personally think that this one is probably interesting, is the water network distribution system for Ho Chi Minh City, which we believe it's, well, can be interesting for India, can be relevant for India because it's a very big city. We are talking about 9 million people in this city. The water network is huge, is not new as everywhere, let's say, around the globe. And so there are sections, as we can see here on this slide, that are dating back to the colonial era. So, well, I mean, I'm Italian, so we're used to have also a section of our water network that comes from the Romans. So we think we have a nice challenge here to really have the opportunity to improve the way Ho Chi Minh City can distribute the water here. So we always have to think that all of these big projects are a real challenge, also because of the increasing pressure you have on financials, on results, on quality. So the population is growing, so they're really interesting projects. So we can go to the next slide, please. Now we have a target here to decrease, of course, the non-revenue water. So percentage is always a bit difficult maybe to be computed, but for sure here we have a significant target in reducing the leakages. And so the solution here is renewing the automation, but together with an integrated leakage system capable to detect and also to say where the problem is, and then to help the people to fix the problem. So this is probably one of the most important characteristics of this project. And here you can see the saving that SWWW is estimating. So 50 million cube meters per year, and well, that's also a financial target of 10 million saving. So this is what will be the target to be achieved. It's interesting. It's also a challenge for everybody, and yeah, we're actively working since a while on this project, and we think it's interesting to know also for India. You can go next. Well, this is a different story here. It is again water distribution, let's say, but also we have wastewater into this area. The customer here, well, this is a city. It's not a very big city because it's 150,000 people, so it's not big. But what is interesting here is the integration between the different areas of the city, because this will be in the end a smart city project. What is already in place here is the optimization of district heating, which belongs to the same utility here. The name of the utility is Mala Energy, we will see in a while. But this utility is playing also in the water area. And so they are managing the distribution network, as well as they are managing waste water plant, so waste plant to treat the water. No? So the interesting thing here is the integration of the different aspects under the same utility, and how to really improve the quality of life of the people, starting from these two aspects. So the district heating, the water. There will be other things that we will put together into the same, let's say, control room in the end of the day. Oh, you can go to the next slide, please. So again, we are talking about automation. We think that probably the most interesting topic on this project is this that you see, ABB Ability cockpit. That means that we are able to integrate into one single pane of glass the different systems that are under it. And this is very important in order to have, well, first of all, a better life for the people in the control room. I mean, they need to make decisions. And if they have to jump from one system to another one, because one is the SCADA and the other one is maybe let's say the predictive maintenance, for example, system, or maybe the energy optimization system, and so on, or maybe the leakage system. And so that is becoming very difficult. If you have one single cockpit, you can also integrate under it the different, let's say, data you have, and making new analytics that are cross analytics, suggesting the best decision to be taken. So in order to really have a data-driven type of decision for this company, this has been selected as an interesting project from them, because we really enable them to achieve this result. You can go next. The idea here is for Mala Energy to create a new digital services, new high-level, high-value digital services. And all this system is cloud-based, so we can deploy system from the site to the edge to the cloud, even intercloud. So for us, it's not a problem. But in this case, the selected solution was fully cloud-based. And the target, of course, is increasing efficiency, reducing cost, and optimizing the operation there. Okay, next, please. Okay, this is the overall solution that we think is probably one of the most important idea beneath these projects. So the idea is not just to tackle one aspect of the problem here, so to be able to have a system for predictive maintenance, or a solution for energy optimization and process optimization, another one for leakage detection, and so on, the Gs are Gs, but really to make all of this system capable to interact and work together into one single cockpit view that can manage all the underneath systems. So you see here you have the SCADA, and you have on the right you have the energy efficiency capability, the predictive maintenance on the asset, the quality of the water monitoring and reporting, and also simulation. So we also have hydraulic modeling for simulation that are integrated into this solution. So really to integrate everything into one system that can help the operator to take the best decision. We are also testing AI knowledge assistants that can interact like we have at home, maybe with the Google Home, or maybe other system. You can really talk to the system and to and have a conversation with AI on the best solutions. So this is not yet product, but we are running pilot on this, and this is another way to help operators in optimizing and taking decisions. Yeah, thanks. That's all I think.
Thanks, Pierre. And we'll just move straight into Morten Reeve, Group Director of Grundfos. For more than 25 years, Morten has worked in the field of technology and engineering, working with advanced systems and in recent years focused on both energy and water. And straight over to you, Morten. Thank you.
Thank you very much, Jen, and namaste to all. If you take the first slide, please. Allow me to introduce, just by adding some overall perspective to the importance of water in a sustainability context, because that's also what we talk about here. So looking at the water in the context of the UN framework of the Sustainable Development Goals, SDG 6 on water is truly essential, as illustrated here to the right. Water, energy, food and health are heavily independent, but likewise the industry is heavily relies on water. And looking at the so-called water footprint, it always surprises me when, an example, manufacturing electronics requires water, or even producing a pair of jeans. And talking about industries and bringing a digital perspective onto sustainability, as introduced by Eva and a keynote, without going further into it, perfectly makes sense to borrow learnings from Industry 4.0, the fourth wave of industrial revolution. For me, there's no question about the importance of digitalization, also in a broader context of sustainability. Now, we are talking about a new normal, and in these unfortunate times, there is a renewed focus on essential services such as water and energy. And just to quote Fred, the moderator of today's program, from a recent article, this can also serve as an opportunity for us to reset, recalibrate, and accelerate. One way or the other, with the huge impact water has on several of these, all the good people attending this conference certainly plays an extremely important role. That is to provide smart water solutions. Next slide, please. So, looking at Grundfos, we have during the latest decades taken innovation steps in the digital direction. We definitely still take pride in providing best available pumps, but likewise adding advanced control aspects to it. And finally, during the last plus 10 years or so, we have added an even more holistic view to our offerings in order to optimize the overall value of our solutions, named iSolutions. Please take the next slide. So when taking a tech stack perspective, here illustrated by the SWAN model, we have accordingly added these layers to our solutions and introduced new technologies. Now, one thing is the technologies as such, but at the same time, I would like here also to advocate for an integrated approach to water, thus aiming for a resilient infrastructure. And as shown in this slide, in Grundfos, we also embrace a water cycle perspective, also previously addressed. So how can our solutions and application help overcoming the challenges within the water cycle? Some shown in the figure here, besides, of course, support optimization throughout the water cycle. Thirdly, I would like to emphasize the huge opportunity to bring a smart approach into the business processes as such. And what I mean by this is that digitalization not only relates to operation, but likewise into all processes, as illustrated to the right. An example, when designing dosing solutions or even pumping station, smart design tools are available. And recently, as another example, related to service and maintenance, we have intensified the focus on aspects such as conditional monitoring, likewise addressed by Becky in her presentation. And here, Grundfos Machine Health supports predictive maintenance in order to prevent downtime, as well as secure a longer life cycle of the equipment. So indeed, a smart approach to our entire set of processes will definitely optimize your water business. So maybe just a short reflection back to the Sustainable Development Goals, where SDG 17 is actually about partnerships. And in Grundfos, we see partnership as a right and much faster way forward. Next slide, please. So just want to take a few examples here where you could say water meets smart cities, where I know for sure smart cities is also on the agenda in India. The first example is about securing safe water, drinking water. And here the smart water treatment solutions likewise secure better working conditions for our water heroes in the field. No transport of chlorine, just salt and energy. The second is about reducing water loss within the distribution system, which we globally see is a huge challenge. When introducing a 24/7 water supply, which I understand and can see is the next panel dialogue, you actually have the opportunity to control the pressure in the system by advanced pump control, meaning you can reduce the water loss as well as the energy consumption by keeping the pressure at the exact needed level. Or actually, you don't have to do that. The pump controller does this by using an adaptive algorithm with continuously learning from the distribution network. And finally, my last example here is that actually a smart approach is not only for large cities. The focus from His Excellency Prime Minister Modi in providing pipe water in rural districts by 2024 can likewise be done in a smart way and even energy neutral. So the last example here is that solar powered pumping station and treatment solutions can play an important part in this mission and even introduce smart water ATMs. And I just want to stress here at the end, the latter two examples is actually developed and produced in cooperation with great Indian colleagues, ready also, of course, to serve the Indian market further with these solutions. So Jen, if you turn to the final slide, I'll just end by saying there's definitely need to continue pioneering water solution. And I'm proud to have 19,000 colleagues around the world to support our way forward. And we will be ready for the next 75 years as well and onwards. Thank you, or should I say, Danya Wat.
Thank you very much, Morten. And we are moving quickly through time. So Ken, over to you. I'll just let you introduce yourself briefly, if that's okay.
Great, thank you, Jen. Really quickly, I'm part of our digital solutions team for Jacobs Technology, and we really focus on digital transformation for our customers from planning through operations and really help them through the whole digital transformation process. We're really proud that this year Frost & Sullivan actually awarded Jacobs the Digital Water Company of the Year. That reflects a lot of work we've been doing over the last decade. Next slide. So the digital water utility is known by a lot of names: smart water grid, smart water utility, intelligent water utility, intelligent water system, data-driven water utility. We like to call them a lot of names in our industry, but what it really boils down to, it helps to overlay data collection, information creation, and provide insight to improve efficiency and decision-making for your organization. Next slide. The digital transformation really does unlock the value of data. Traditionally, water utilities have a large number of different types of systems, from advanced meter infrastructure, geographic information systems, LIMS, SCADA, and they typically go into individuals that manage that data, and they tend to stay in silos. And when they're in silos, you really don't get to be able to share the information as necessary. What a digital transformation does, it allows the data to go into a common data platform where you can do integration and analytics. And you can do things like descriptive, predictive, and prescriptive types of analytics. And then everybody in the organization has the access to that information they can use to fulfill their individual business needs. And that really provides you the maximum value for the data you're producing, which is not cheap, and utilities really need to be able to obtain that high value for the data. Next slide. So what are the characteristics of a digital water utility? First and foremost, you need a strategy and a vision. You have to understand what you're trying to accomplish, what your key pain points are that you want to be able to solve, and how does that vision fit with the mission vision of your organization. Developing the strategy is not foreign to the water utility. We've been developing those for our water systems and wastewater systems. Think about not having a water system master plan and arbitrarily putting pipes and pumps and reservoirs in the ground without really understanding how they all work together. That would be an absolute failure. And the same thing happens with a digital utility, where you need to make sure that all the pieces you're putting together really work seamlessly together. You want to look at risk resiliency, and as you start to put projects in place, look for ways you can reduce the risk for your agency and increase resiliency, like climate change. Third is the workforce. It's really important to understand how prepared is your workforce to go into a digital transformation process. Do they need more training? Are there some skills that are missing? And really to understand what those needs are before you throw a bunch of technology into the work and say, okay, use it now. And it's not going to be very effective. Next is asset management. One of the goals of a digital water utility is to go from reactive maintenance to proactive maintenance. Reactive maintenance costs about 3 to 4 times more than proactive predictive maintenance does. And you really want to be able to move that over so you can actually get longer life out of your assets and reduce your overall cost of your operations maintenance. Next is data management. When you go to digital utility, you're going to have much larger data sets to manage and a much higher velocity of the data coming in. If you haven't thought about that ahead of time, you're going to be overwhelmed with data and you're not going to be able to make a lot of sense out of it. And it really is going to minimize how effective your program can be. Next is integration, interoperability. Back to the strategy and vision. You want to make sure as you start to put these different solutions like non-revenue water, digital twins, water quality monitoring, pressure management into play, that they're developed in a way that they all work together so you can start to do integration and overlay of those different types of information streams. And last of all, you really need to look at your capabilities for data analytics and how you're going to use that information. These data sets, again, are going to be very large, but data by itself is really pretty much meaningless. What you want to do is create that data, process it real time or near real time into information that can be used to make rapid decisions as part of your overall operations of your system. Next slide. So when you go through this process, you're going to get some scores on how well your utility actually is ready for going through a digital transformation. What it doesn't mean is that you're bad. The reality is that a lot of utilities haven't been thinking about digital applications, and in those cases, they may not have a lot of knowledge about how to use it for maintenance, how to use it for distribution system operations, for water treatment operations. So what this does, it allows you to look at your maturity level and decide, based on where my organization is, what do I need to focus on as I start to put these new solutions in place, so I can not only put new technology in place, I can have the right processes, and the workforce, the people are going to be ready to embrace the solution and again provide maximum value for your investment. Next slide. We've talked to the largest water and wastewater utilities in North America and asked the chief information officers 2 questions. Can you process big data in real time? And only 13% of the largest, most sophisticated water agencies felt that they could do that, because again, it has not been part of their focus in the past. Then we asked them the other question: of all the data you collect, and trust me, I came from a utility background for 20 years, we're really good at collecting data. How much of that do you actually utilize? And they said about 10%. So there's all this dark data that's sitting in there, being collected and not really providing value for the organization. So we always think about the value of now, that certain information whose value decays exponentially over time. You need to perform real-time analytics on data, provide real-time intelligence. Example, if you have a pipeline break and you can detect that break when it's first starting to seep, opposed to when it actually burst and you have water gushing out of the ground, your cost of maintenance, your cost of impact on your customers is going to be significantly less. So an example is in New York City, where they had customer complaints, and I had a major water quality problem in the organization, and unfortunately the digitization isn't working here. But what they did over a 2-week period, they were able to capture the customer calls and find out where that water was in the distribution system, and actually go there and do focused flushing. This is a city of 16.5 million people, and you really can't go out and flush a system for 16.5 million people. So allow them to understand where their water had migrated to, got rid of it quickly, and were able to reduce the amount of water for flushing and quickly take the poor water out of the system. Next slide. So this is an example in a city in North America that actually went through the whole process of doing a digital maturity model and then actually putting their strategic plan together. And this is a result of their overall structure, where they have their system of records. Those go into application layers, which feed into their analytic layer and integration, and then it's open to their entire organization. And the whole concept is taking data from information to knowledge to wisdom. And that's what digital transformation is all about. Next slide. So some closing thoughts is the digital transformation journey is a complex process, and this could require proper planning. And rather than, I would say, don't jump in and just buy a bunch of technology because it looks cool. Make sure that it fits in your overall program. Creating that strategic plan really provides a focus on how and when you implement different types of solutions. It's really critical for the utilities to understand the organizational strengths and the organizational weaknesses, so as they start to put their digital transformation in place, they can actually achieve those goals and strengthen the weak areas. And last of all, assessing the digital maturity of a utility really provides the roadmap to go through your digital transformation process. Jen, back to you.
That this will be the saying of 2020, you're on mute. But thanks very much, Ken, and thank you to all the panelists. We probably don't have time today to do a Q&A, but I really encourage everybody to put your questions in the chat box and make sure that you really take advantage of your panelists while you're here, and they'll respond back to you at this point, over the course of the next half hour or so. So, Fred, back to you. Thanks very much.
Thanks, Jen. Yeah, with regards to questions, yeah, we'll just pass it on to the panelists, and it would be great if the panelists could address that, because there are quite a few questions which are coming on, and it would be great if that gets answered. Thanks, Jen. Moving quickly on to our panel 2, as it were. So the title is Digital Solutions Enabling 24/7 Water Services. And it's my pleasure to introduce our moderator for the panel, Chuck Hansen. Quite, what should I say, rock star for the water sector. He's the founder for Electroscan, a non-acoustic machine intelligent leakage detection technology. And before Electroscan, Chuck was the founder of Hansen Software, which was used by more than 2,000 water utilities, starting the company in 1980, and then led to selling it off in 2007 and making a cool $100 million for it. Yeah, he loves his music, is a keen saxophone player, has a good collection of saxophones, and also has a song which is going to be released with a friend, Huey Lewis, this week. Chuck, over to you.
Quite the introduction. Thanks so much. Delighted to be here. Good morning, good evening, good afternoon. I am delighted to be moderating this session, and yes, it's been a great 40 years in the industry. I think we want to get right on to introductions, and so as you see the faces, we'll be talking and presenting briefly from each of the presenters. The first, Andrew Donnelly. Andrew has been an advisor for the last 15 years to the board of EPAL. But in addition to that, he has also been the head of leakage management. So I think what you're going to see with Ipal is some real live. If you just go back to that screen, we'll just introduce each one. You'll see some really some good history of what he's accomplished over that time. Our second speaker is going to be Tom Woolley. Tom is 2 years in his role with AquaSuite, rolling out that on behalf of Royal Hansburg, DHV, rolling that out into North America, the UK, and India. He's had over 15 years experience in smart water, intelligent controls, and just a wonderful case study he's going to be presenting, real world project in India. The next speaker after that will be Delph Mack. Delph is a rising star at Xylem. She is the regional director for Xylem Digital Solutions. She's going to be with us out of Singapore, so great to have her. And again, I realize in India cricket, your cleanup hitter is usually number 3. I'm the American moderating, so the cleanup batter is always number 4, and that is Apendra Bhuta, and he's got over 20 years of experience with advanced ultrasonic meter. And what I love about his conversation, he's going to be talking about the user and what automated meeting reading really impacts the end user for that. So next slide. So I'm not sure if this is the one, but they've added this in. So I'm going to say, take it away, Andrew, and let's see what slide stack they provided for you. Andrew from Lisbon, you there?
Hi, good morning, everybody. Good morning, good evening, good afternoon. I hope everybody's well. A pleasure to be here. If you could go to the next slide, I hope my first slide will be there. It is indeed. Okay, so Epal is Portugal's largest and water holder supplier. We supply around 1/3 of the country, with bulk supplied with the municipal suppliers, and we also do direct supply to around 350,000 clients here in the city of Lisbon. Over the last few years, what we've done is we've set up, we maintain a very successful DMA monitoring project. I call it the classic solution, if you like, a network of about 1,500 kilometers segmented into about 160 DMAs, supported with our own telemetry and data management software, which we've developed in the company, to help and assist our active leakage control teams with doing leakage detection campaigns within those DMAs. As well as that, it's provided enhanced network management, greater resilience, greater diagnostics, and I think the results have been highly positive. As you can see from the graph here, we started from 2005, 2006, and during the 4 or 5 years of the project implementation, non-revenue water went down nicely until about 2011, where we ended up in a steady state system. So we have the systems, we have the tools, we have the data, and we know how to interpret and use the data. We have the staff, very important, and we have a consistently good performance. But 2016 and then 2017, we had a new problem. The graph started going up again, so we had to start looking around our data to see where the problem was. If you can go to the next slide, please. So what happened was the problem was identified in 2 supply zones. The city has 5 supply zones. We are specifically in 2 supply zones. And these are about 150 kilometers of large diameter mains. So these are 400, 500 millimeter diameter mains up to 1,500 millimeters. And they're outside of the permanently monitored DMAs. So the monitoring and the metering that we have on these larger mains is not sufficiently accurate to permit the identification of leaks or assess the leakage potential on them. So what we did was, having eliminated 95% of the network, what we started on was using the existing infrastructure and the existing data to try and pinpoint more accurately where we thought the big leaks were. So what we did was a new assessment method using temporary segmentation of these large diameter mains, where we used the DMAs and the DMA meters and telemetry to actually monitor these large diameter mains. So what we did was we interconnected 2 or 3 more DMAs, and we fed back the DMA meters onto the trunk mains. The objective for this, the output, was to identify critical sections for specialist leak detection interventions. And these are, as I said, large diameter mains up to 1500 millimeters. The company doesn't have equipment to work under these conditions, and contracting service provision for leak detection on these mains is expensive. It's time consuming, it involves a lot of preparation, and it can also be very demanding in terms of network operations. So obviously we wanted to really pinpoint which were the sections that we had to do this on, and that's exactly what we achieved. If you can go to the next slide. So what happened was the smaller mains where we used standard leak detection methods, so it's up to about 400 millimeters we could do ourselves. And then what was contracted was a Sahara campaign with 11 surveys over 10.5 kilometers of mains. We found 26 leaks there, and a smart ball trial, first time they've used the smart ball system, just with 1 survey on a section of 500, 600 millimeter main, and we found 11 leaks there. The results were quite dramatic. Sahara repairs were completed earlier this year. You will note that it took 3 years to complete all those repairs. This was, at some locations, quite a concern for us, because we knew the sensitivity of where the leaks were and if there was a burst at that locations. But we don't control when and where we can do the repairs. We're at the mercy of the city council and the police to authorize those repairs. So that's why it took so long. Smart ball required other leak detection techniques to help us actually pinpoint the location for those. But again, successful repairs were done there. The non-revenue water in those 2 supply zones was reduced by 20 and 45%. That's around 2 million cubic meters per year. And this all feeds into our future strategy. We're going to look at installing additional trunk mains to permit more of these temporary trials. We develop a temporary meter zone plan for other years, so we're trying to repeat it regularly, and that leading on to repeating the in-pipe specialist leak detection campaigns on a regular basis. Given for us, there's a clear cost benefit for having done so. You can go to the next slide. Obviously, the results have been quite dramatic. 2018 and 2019, we've got a downward trend again. 2020 is looking quite good so far, although we do have different trends in our water consumption patterns this year. So positive response to increasing, to looking at our non-revenue water and the overall company balance. We have to continue the fundamental DMA and active leakage control work, using the data that we've created, but not using just it on a basic level to look at what the DMAs are using, to see how else we can use that data and apply it in other areas. So we've got significant positive results from that. We've limited the impact on the network with restricted resources and restricted finances. So a very targeted solution for specific non-revenue water origins. And we're always saying about smart systems and smart data, but sometimes we need to use that data smartly. So it's common sense solutions, and we can't forget what is the true smart element of our systems. It's us, smart people. We have to be creative with the data that we've got, with the infrastructure that we've got, with the problems and the challenges that we have. So if there's one fundamental message there, is to value ourselves, our teams and our colleagues and the work that we do together. So thank you very much.
Great. Thanks, Andrew. Andrew, I've got a question before we go on. And the question is, I noticed in one of your slides that you investigated 10.5 kilometers of pipe, but only came up with something like 26 leaks. And you do a back of the envelope check on that, and you know, it seems like just based on the number of joints. Since I went to Berkeley as an undergrad, I look at those things. It seems like the pipes were near perfect. Could you give the audience a little bit more information on the leaks, and when you found and fixed them, what did you happen to find on those 26 leaks?
It's a good and it's a pertinent question as well. The size of mains that we're working on, each section, the concrete mains are 4 meters long. So you are talking hundreds, literally thousands of joints between those sections. And you can have 99.9% of them working, functioning perfectly with no leaks. But if that 0.1% is in a sensitive location, and that you're risking a big leak or a burst or having the road surface undermined, leakage into a third party property, then you're at big risk. The majority of the mains that we did with the Sahara campaign were laid under the main freeways, dual carriageways, the main roads that cross through the city of Lisbon. The potential consequences if there was an unplanned burst in one of those locations were considerable. Hence, it wasn't just an initiative to reduce the non-revenue water headline value percentage or cubic meters. It was a risk avoidance strategy from us to make sure that we could proactively control where those repairs were done, when and where, to avoid major disruption within the city. So it was about risk control as well as non-revenue water control. So we were extremely happy with both sets of results there, both the cubic meters that were recovered in those repairs, as well as avoiding a major issue within the city.
Yeah, that's right. Great example. I think one of the other messages when you did dig these up, were these leaks caused by a gradual decline in the pipe? You know how a lot of our models take diameter and year installed, and so we estimate what pipes need to be fixed. I think you mentioned 25 out of 26 of these leaks had a particular issue with them. What did you find on those?
Indeed, actually, all bar one of the repairs that we did. I have to say that all the leak locations were absolutely correct. 100%. There was no failure on the leak location part. 25 of the 26 were actually on the rubber joints between the mains themselves. There was actually only one structural failure of the main itself. So from that point of view, it was an interesting data to have. And of course, that feeds into the network renewals process. Do we need to renew the actual structure of the main itself or just the joints? The answer in that case was just the joints.